No, du is gone when you integrate. The du is just to signify what the variable is. I don't. I do. But it's a bit tattered. Anyways, we're going to start the next lesson now in a minute, so. What do you mean, no? Yeah.
This question. So.
Good. Good. That's good.
Why trying to substitute u back to the x, which is
1 plus x, yeah.
Yeah. That is correct.
Yeah.
The answer is
Minus sign is differentiation.
What's wrong with the answer?
x is not 1 plus x.
But I told you. I did this example. I said the one can be
constants.
absorbed. Ready?
No, do they give general formula questions in the exam?
What do you mean?
Like this one? Like the last
2,
one?
3, 4, 5.
No, but I can't see any reason why they couldn't.
Yeah.
So. Right. Which power?
No, that's
any negative
Uh,
you log it.
well, it depends if you're integrating or differentiating. But I mean, are you talking about the final answer?
Yeah.
They usually don't mind. I personally like to take the power down. But I mean, there's sometimes in the exam, my experience is when the power is a fraction, they're quite happy for you to leave it as a fraction. But when it's -1, they kind of expect the student would write that as 1 over. But I doubt that there's any marks at stake. No. Okay, yeah.
When we're done with the book, are you just going to do passing quiz for the exam?
Yeah. Well, we'll have to talk about the coursework as well. Yeah. And I don't know. We might do some Charles stuff. I'm not sure. We'll see. Anyways, to answer your question, yeah, we'll just be looking at past papers.
When will you get the grade for coursework?
Coursework 1. I still don't have confirmation that I can correct it yet. I'm waiting for the green light for that. But I haven't been granted permission yet to land, so I can't do anything right now with it. There's a couple of things I need to check before I can correct it, and nobody has answered my question yet, despite asking 3 or 4 times.
Sounds like me.
No, I do answer your questions. Not only that, I promise to answer 3 questions. It's a guarantee. Yeah. Okay. See, you're thinking you're wasting your questions on maths questions. You can be asking me things like, what's my favorite color? What's my favorite ethnic food? I mean, you're using them up on maths questions. No. The offer doesn't extend to you, you know. Yeah, that's right, yeah. He has premium questions. Yeah. Okay. So, integration of simple rational functions. By rational function, what we mean is a function which is a fraction, and on the top and the bottom could be something like a linear or a quadratic. So just, well, you can see on the page, everything on that page 150, they're all rational functions. Can you see that? So for example, in question 1, we have a linear and a quadratic. Number 2, linear and linear. Number 3, constant and linear, and a constant and quadratic. And number 4, constant and quadratic. Okay? Now, before we get started on integrating these, there's one little rule that we just have to prove, but it was actually a question all the way back on page 146. The last question on 146. Did anybody get that? The last one on 146. Where I ask you to differentiate this. Yeah, now I'm going to do that one because we need its result for today's lesson. So, does anyone remember what should I do first? Tan both sides. Like that. Now I differentiate. So what's the derivative of tan? 1 over cos squared y. And dy dx. And derivative of x? 1. So what does dy dx equal? Cos squared y. Now if I draw a triangle here, what's the opposite? What? A triangle that represents this statement. X. Because this is like x over 1. And what's the adjacent? 1. And the hypotenuse? Square root 1 plus x squared. And this here is y. So therefore, what is cos y? Cos y would be what? 1 over? Yeah, root 1 plus x squared. But I have cos squared y. So that's 1 over? Oh. Yeah, 1 plus x squared. No, the square removed the root here. Therefore, the derivative of tan inverse x is 1 over 1 plus x squared. So that means the integration of 1 over 1 plus x squared is equal to tan inverse x plus c. So remember, if I have, say, f and g, and I tell you the derivative of f gives me g, therefore, the integration of g brings me back to f. So if the derivative of tan inverse x is this, then the integration of this brings me back to tan inverse x. Now, just so you know, this is the only proof I've seen them ask in the past papers, as in like prove a formula. Okay, so they've never asked you to prove like the quadratic formula or what the whatever. The only formula that I've ever seen them ask you to prove, well, that's not true. There's two. They've this one, and the other thing that they've asked you to prove is derivative of tan x is 1 over cos squared x, but you can prove that using which rule? Yeah, the quotient rule. If you use the quotient rule, you can prove that. Huh? Yeah. Yeah. No. If you change tan x to, well, what would you change tan x to? Oh! You say the derivative of tan x is secant squared, and then secant squared is 1 over cos squared. That's cute, but no. You can't do that. That's no. No, because secant squared and 1 over cos squared is the same thing. So it's like you're saying, derivative of tan x is blah. And blah is 1 over cos squared. Therefore, I'm finished. So no. It's a nice try. It's a good try, actually, but no, not this. So you might want to write this proof down, because like I said, I've seen it once in the exam, so maybe it could come up again.
Can we solve the previous question with secant squared
What do you mean?
instead of 1 over cosine squared?
Could you write the answer as secant squared? Yeah, if you want to, you could write this as equal to secant squared x. That's fine. But 1 over cos squared is fine too. Okay, so please write this proof down carefully. Like I said, what? No, the other ones. No, just write this down. We need this result for today's second lesson. So. Okay, do we have that? Yep. Right. So remember that result, we'll need it. We're going to look at 4 examples, 4 types of problems for the exam, starting with the easiest one. So the first one is, how would you integrate something that's a linear, like minus 8x plus 6, over a quadratic? Minus 4x squared plus 6x plus 5 dx. Now the good news is, it's the first one and it's the easiest one, and the substitution is what you would guess. U equal to minus 4x squared plus 6x plus 5. Du dx, what's that equal to?
Minus 8x.
Minus 8x plus 6. So that means dx is du over minus 8x plus 6. We return to this question. We get integrate minus 8x plus 6 over u du over minus 8x plus 6. Now that's really nice, because what happens here? Yeah, how? That and that cancel. So you're left with integrating 1 over u, which is log u plus c. So the answer is log minus 4x squared plus 6x plus 5 plus c. And Amjad, if you want to be picky, because the quadratic could be negative, we can force it to be positive by putting these absolute value signs around it. But don't need to worry about that so much in the exam.
What if the numerator does not simplify with the denominator?
Yeah, well, what we're looking at, we're going to look at 4 examples. So, situation 2 is when that happens.
That looks like a coincidence. You cancel the numerator and denominator.
Doesn't it?
Looks like coincidence.
Well, it is, because I designed the question for that to happen. But of course, there's no guarantee that that should happen, which is why we're going to have a look at more examples now. So, ultimately, Young Peng, this is working up to, for example, like pages 160 and 162, where you're given any sort of random quadratic and random cubic, not just ones that simplify nicely like this. Okay, can I go on to the next example? Yeah. So, next example. We want to integrate 6x minus 7 over 2x minus 9 dx. The good news is it's the same substitution. U equal to 2x minus 9. So that means du dx equals 2, which means dx equals du over 2. Fine and dandy. So this is 6x minus 7 over u du over 2. Well, I can at least take the 2 out. So that's a half 6x minus 7 over u du. Now, we've seen this problem before. Our 6x minus 7 didn't cancel away. So what do we do? Rearrange, yeah. So if you take this guy here, you can change that into. Now, yeah, you could get u plus 9 over 2. Okay, but if you're smart, you can make your life a lot easier if you multiply this by 3. Right? And then 3u plus 27 equals 6x. And then you take 7 away from both sides. So you get 3u plus 20 equals 6x minus 7. That's where he was going. Isn't that a lot easier to replace? Yeah. So instead of 6x minus 7, what have I got? 3u plus 20 over u du. And again, we've seen what happens next. What do we do next? Yeah, by splitting them. So this is a half integrate 3u over u. 3u over u. 3u over u becomes 3. And then the next one?
20 over u.
20 over u. What's wrong?
Why don't you simplify before?
Over 4.
Yeah, no, it will be 3u over u, which is 3.
Yeah.
Yeah, you like in the integration. Oh, okay.
Okay.
Oh,
Continue?
yeah.
Right. So this is a half. And what does the 3 integrate to?
3.
Yeah, well, in this case, 3u. And this is 20 log u plus c. So this is 3 over 2 u. And what's the u, did we say? 2x minus 9 plus 20 log 2x minus 9 plus c.
Remove the constants.
Yeah, if you like, you can change this into 3 over 2 times 2. 3x plus 20 log 2x minus 9 and plus c. The c can absorb the 27 over 2. Yeah. Again. What are you asking me? The stupid way? What do you mean the stupid way?
The basic way.
You mean on the last step?
Without using the 3.
Without using the 3.
Which means the 3u plus 20. The one.
Are we talking about here to here?
You just replace up,
Here?
top right.
Oh, this!
Yeah.
Oh, you didn't like that? Okay, fine. Fine. This is what you, okay. I understand what you mean now. This was too clever. Okay, so if you take this, you can change that into u plus 9 equals 2x. So u plus 9 over 2 equals x. Yeah? And now if we go back to this line, we can change this into a half integrate 6x, which is u plus 9 over 2 minus 7 over u. Now you can see why I was trying to avoid this. But now we have to clean this up. It's not actually that bad to clean up, because here you have a 6 and here you have a 2. So they cancel down to 3 bracket u plus 9 minus 7 over u du. And then we can multiply in the 3. So that's 3u plus 27 minus 7 over u, which is a half 3u plus 20 over u du. And now I'm back at this step. So I cut out, me being smart here, cut out these 4 steps going from here to here. But now I'm back on track at this line.
What?
Yeah?
Final answer, would it be 10 log? Because
10 log.
half is
Oh, thank you, thank you. I forgot that this. No, actually, it wouldn't be 10. It'd be 60 over 2. It'd be 30. Here.
Yeah, 'cause you.
But I didn't multiply in the.
No, you
Yeah.
have the half.
Oh, did I? Oh, of course I did. Sorry, thank you. Thank you. That should have been
10.
10. So that means here that's
10.
10. Thank you. Okay. Now we're getting trickier.
What are you going to have
Hmm?
lunch? What's your lunch?
My lunch. You want to use up your second question on that? All right. Okay. Now we're getting interesting. So my lunch
Probably
today
go to the mosque.
is not today. Not today. I went last week. I try not to splurge too much. I will have some vegetable soup and brown soda bread. Not a big lunch, so I might have to top it up with something else.
Doesn't seem big enough.
It's not. I'll probably have to top it up with a piece of chocolate, maybe, or something. Something afterwards. Maybe I'll wander down to the mosque and get some coffee and cake. It's not a bad idea. Not a bad idea. All right, do we have that written down? No. If you look at their Facebook page, the mosque's Facebook page, you'll see there's a video of me on it. Did anyone see this? No? All right. Myself and Lorraine went there on the open day, and they were showing it around. So they said, "Oh, we can interview, ask a couple of questions." So they asked me questions, and I did my best. Oh, blah 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 blah. Yes, it's important. Shared cultural heritage. Blah 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 blah. blah. So,
Food.
yeah. At the time, and I'm also thinking, when am I getting the free food? Free food, where's it coming in? No, they were very smart. They gave me the free food first and then asked for the videos. You see, that's thinking,
Well, no, that's not actually.
No, it is, because, I'm relaxed. And,
They're bribing you.
yeah, that's it, yeah.
What's the point?
No, you have to say
You do the job, then you give them the
Ah, yeah, but gratitude, I'm not going to say, but this, firstly, the food was terrible, okay? That's my first thing I have to say, They had all the nice, baklava and all this delicious stuff, and the Arabic coffee as well. I'm not too mad on it. An acquired taste, I think.
It is very
It's,
just
yeah,
like
Very strong.
No,
it's a bit strong.
Yeah.
Well, it depends which one you get.
Very
Coffee strong.
I don't like Arabic coffee is very
Like an
Turkish
espresso.
coffee is very strong.
It's like an espresso.
Turkish is very
You like it? Yeah. Well, you're drinking Red Bull, so
I don't think
you have peculiar taste, is what I'm saying. I can't stand those drinks. Yeah. I find it amazing that some of you drink it.
other people.
As a student, you have no choice.
You have no taste, it would seem, as well. Okay, next one. Okay, next now. Number 3. So we want to integrate something like 16 over 4x squared plus 1 dx. Okay, so this one here is our first example where the substitution is not simply u equals 4x squared plus 1. I don't know if anyone has any ideas on what you could substitute then if you're not going to substitute 4x squared plus 1. Maybe 2x plus 1, yeah. Factors? It doesn't actually have factors, does it? No, it doesn't have factors.
There's only one factor, which is 2x plus 1.
That isn't even a factor. Yeah.
No factors.
Okay, yeah, 2x perhaps. So this is the trick here. What you do is you let u equal to the square root of the first piece over the second piece. Now, that means you'll say let u equal to 4x squared over 1, which means you're saying let u equal to 2x over 1, which means, like you said, Amjad, you're simply saying let u equal to 2x. And that means du dx, that will equal 2. So dx will equal du over 2. Now, we'll go back here and we'll say this is 16 over, and the dx is du over 2. Well, now, what about this 4x squared plus 1?
U plus
U
1.
square.
Yeah, well, if you look at this line, what does x equal? U over 2. So this is 4 times u over 2 squared plus 1. Now you might be saying, this isn't making it easier, is it? Well, watch what happens now.
It's 4u square.
Yeah, it will be 16 and 2, what does that become? 8 du. Okay, that's fine. And then this is 4u squared over 4, which is what?
U square.
U squared plus 1. So this is 8 integrate 1 over u squared plus 1 du. No, now you should recognize this is a special integration. I'll give you a clue. It was the very first thing I did with you in this lesson. No, tan inverse. It is literally the first rule I proved today, wherever it's gone. Integrating 1 over 1 plus x squared becomes tan inverse x. So if I return now back to my question, this integrates to what? 8 tan inverse u plus c. So finally, that's 8 tan inverse 2x, yeah, plus c. So the reason for doing this trick here is so that you can take this and turn it into this integration. That's the reason for this strange choice here. It's a quite strange choice, but it works to reduce this problem into this problem. Yeah?
So why did you do it over 1? It's just you said
I just want to give you the rule.
you said something and you said something 4x squared over something. Why?
Basically, you make u equal to the root of the first term over the second term.
Oh,
Now, in this case, the second term happened to be 1, but I mean, it could have been like 9, you know, whatever it is.
If you have 3 terms and they don't factor.
That's the next example. I'm doing that teaching thing, you know, the scaffolding, where like I build it up bit by bit, and the lesson has an overall direction and objective. Yeah, yeah.
That was me, I would have lost that question.
You would have wasted it. Yeah. Aren't you glad he asked it?
I wasn't planning that.
Okay, well now you know, anyways.
This is
Yeah.
a very dumb question to ask.
He's sick. He's sick. Okay, Amjad, yes.
If we divided by 8, should we write c over 8 or c?
It doesn't matter. It doesn't matter because the c stands for any kind of constant.
So can we write tan inverse of x plus c?
Oh, without the 8 here?
Yeah.
Oh no, we can't lose this 8, right? Because it came from here. It's a
So
multiplication.
c divided by 8.
But we can't divide by 8 because it's not equal to anything,
Why did the
right? Like a, yeah, but I'm not sure what you're asking me. I can't just get rid of this 8. There's nothing I can do to get rid of this 8. Now, if I said this is equal to 0, I can divide by 8 and get rid of it. I didn't say that.
Why would you want to calculate the 8?
Would you? Don't ask me. Don't waste your last question on asking me. No. Ask him. Turn around and ask him. Why does he want to get rid of the 8? We can't get rid of the 8. Okay. Right. Question? No? Okay. So, yeah. The step here to here. Here to here? Okay, let's see. Yeah, so I kind of wrote it a bit short, didn't I? So if I just look at what's happening here, it's 4u over 2 squared plus 1. And I change this into 4u squared over 4 because I can put the square inside. And then you can see, well, that's just 4u squared over 4 plus 1. And of course here, the 4's cancel, and that's u squared plus 1. So that's how this denominator changed into this denominator. Is that okay for you? Yeah. Okay, can we go on to the next example? So the next example is what you were thinking of, is what do you do when you have 3 terms, not just 2. Okay, scroll down. Yeah, okay. So we have integrate 16 over 4x squared minus 8x plus 8 dx. Now before I do anything, there is an obvious simplification I can do here.
4 divided by 5.
Divide everything by 4. So let's do that first before we start doing any integration.
4
4 over x squared minus 2x plus 2 dx. Right, well here's the problem. You might think, well, we have several choices here. We could say let u equal to x squared minus 2x plus 2, but we know that won't work.
X minus 1 squared. X minus 1.
Yeah, there we're thinking, yeah. What's that called when you do that?
Twice.
Complete the square. You see, the problem is if we use the other trick, square root, we don't know what 2 terms to use because we have 3 terms. But you can reduce it to 2 terms by completing the square. You can say that this is 4 over x minus 1 squared plus 1. Isn't that completed square?
Yes.
Yeah, it is. So, u could equal square root x minus 1 squared over 1. Which would mean u would equal x minus 1 over 1. Which means u equals x minus 1. And what does du dx equal? 1. So that means du equals dx and dx equals du. So our problem can now be written as 4 over, now we'll have to replace in a moment, and the dx is just du. Well look, what's x minus 1? You can actually see it quite clearly here. X minus 1 is u. So this becomes, now this is looking, of course, familiar, isn't it?
Yes.
We got tan inverse.
Yes.
So this is 4
Tan inverse.
tan inverse u plus c. So finally it's 4 tan inverse x minus 1 plus c. Okay, so that's the answer for that one.
Just 1 extra step.
Yeah. Got it? Yeah.
What's your favorite dish?
Huh?
What's your favorite dish?
Favorite dish? No, too many. I couldn't possibly choose.
I have 3 new questions. You need to provide an answer.
True.
Or you
Let's.
could provide me the refund.
Oh, I see. All right. Satisfaction guaranteed. Anything that has a big piece of meat on it, you know, like a big burger or a big steak, anything like that. Steak dinner, roast potatoes, medium rare, something like this. Yeah. Meat is the key element here. All right, did we write that down?
Does it have to be meat or can it be anything? Could be chicken or fish. Or does it have to be?
No, don't give me any of that screwy vegetarian portobello mushroom tofu or something. Yes,
If you have a cubic as a denominator,
you're really pushing it. Okay, cubic
Yeah.
as a denominator.
then
Okay, yeah.
you would find all the factors and then
Yeah.
make u equal to one of the factors and then substitute.
Well, this is what we're literally trying to work up to on the end of the book.
Oh,
Okay, so again, scaffolding process. Okay, we'll get there. We'll get there.
Another question.
The cubics are extremely difficult. Extremely difficult. Now, in fact, you might think, oh, this is great. So this always works, but there's a huge complication. Imagine that you completed the square, and on this step here, instead of getting +1, you got, say, -1. You might think, no big deal, but when you get to this step and you get -1, Can you change it into tan inverse? No, because the rule is quite clear. It has to be +1. So in fact, even this technique, I have to specially construct the quadratics here so that when you complete the square, you get a plus.
So take the minus out.
But you can't, no, there's no way, because if you take the minus out, you'll introduce a minus here. So you're kind of stuck. So this is my point. Even this example, which seems a bit more general than the previous examples, because as Yung Peng pointed out, my first example seemed quite coincidental that I could cancel. Again, even with this example, I had to specially construct the quadratic. It's not until we start getting to the end of the book where we start to discover techniques that work regardless of the nature of the quadratic. You might figure out that this only works if the quadratic actually has no roots. This quadratic has no roots. That means that this guy here is a plus. If this quadratic had roots, then that would be a minus here. And there's something else to do in those situations, which we'll see later, okay? Again, like I said in the previous lesson, all these are suitable exam questions. You know, I've seen each of these on the exam. Now, number 4, I don't think I've really seen it that much. I can't even remember if or when I've seen it. But I've certainly seen 1, 2, and 3 on the exam. Number 4 might have been a long time ago. Yes?
Do we need to know sine inverse?
No, not the IFY Science. In the other, I think the engineering program you do. But I think you just need to know tan inverse. Yeah, Amjad, just tan inverse, not the other 2. Yeah, because there are other 2 things which integrate to sine inverse and cos inverse.
One more question.
Yeah.
Someone doesn't know that 1 over square plus 1 equals tan inverse. We solve it.
What do you mean? If somebody didn't know what this is,
Yes.
what are you asking?
No. For example, when we know that 1 over u squared plus 1 equals tan inverse, right?
Yeah,
I didn't
Well,
know.
it integrates into.
yeah, it integrates to tan inverse, yeah. So what are you asking me?
Like if I didn't know that
Okay,
tan inverse is,
the integration of that.
yeah,
Yeah, what are you asking me?
can we solve it? By the quotient rule.
By the quotient rule, the quotient's for derivative.
I didn't get my question.
I got your question. Your question is, suppose I want to remember one less thing for the exam. Is there any way I could do this without having to remember that one fact? Yes, there is. You could reprove that formula. Yeah. So, how? This is literally the first thing I did in this lesson. The very first thing I did. Again, just to point out, my lessons have this kind of structure, where the stuff at the beginning is important and leads to the harder stuff.
No, I think it's a circle.
My lessons are a circle. Ah, I see. So we start easy, it gets difficult, but then we're back at the start. Yeah. Like the snake that eats its own tail. Yeah. No, not like this. Okay, did we write this one down? Yeah. So there's about 10 minutes left. So again, that's a good amount of time to practice these. And again, I'll say, Mo, that the U might not be given. So it's really important that you learn how to recognize which of the 4 types of problems you have in front of you. Yeah? Okay, so can you just try these for about 10 minutes and then we'll finish them. Can I close this? Okay. Yeah.
Do you believe we're living in a simulation?
Sorry, this is question time, which means questions revert back to boring maths questions, which are unlimited, but, they're boring maths questions. Sorry.
My
No, we're into free question time, where all maths questions are for free, 100% off. So. Now, look, you don't have a book, so try a couple of them. I can close this. Yeah.